Welcome to the deep dive. Today we're looking at something really fascinating. A newly found interstellar object called 31 ATLS. And we're jumping straight into a pretty provocative question from the research itself.
Right. Could this thing actually be, well, alien technology?
Exactly. So our mission today is to unpack why researchers like Hibbard, Crowell, and Loeb are even asking that. It's all about these anomalous characteristics they found.
Yeah. It's based on some very puzzling observations, both photometric and astrometric. Where do we even start?
Okay, so what's the first big red flag, the first anomaly?
Well, its path, its trajectory. It's highly unusual for something natural. Its orbit is tilted almost completely backward compared to the planets. We're talking about 175 degrees relative to the ecliptic.
175 degrees, so basically going the wrong way around the sun.
Pretty much, yeah. A low retrograde tilt, just about 5 degrees off perfect opposition. And the chance of finding an object on that specific kind of path naturally.
Must be low.
Extremely low. The calculation puts it at around 0.2%, just 0.2%. Yeah,
Wow. Okay, that alone makes you look twice, right?
definitely. And it gets weirder. This object also had some incredibly close encounters with planets in our system.
Oh, yeah. Like which ones?
We're talking Venus, Mars, and Jupiter. It flew past Venus at about 0.65 AU, Mars even closer at 0.19 AU, and Jupiter at 0.36 AU.
So, really threading the needle between planets. What are the odds of that sequence happening by chance?
Vanishingly small. The combined probability of those specific close approaches just happening randomly is estimated at less than 0.0005%.
0.005%. I mean, that's getting into ridiculous territory. You really start to wonder about coincidence at that point.
Precisely. It forces you to ask, okay, what else could be going on?
So beyond its pith, what about just classifying it? Is it an asteroid? A comet?
That's another puzzle. If it's an asteroid, it's huge, maybe 20 kilometers across.
Yeah.
Finding an interstellar asteroid that big should be much, much rarer than finding smaller ones like Oumuamua, based on what we expect.
Okay, so probably not a typical asteroid. What about a comet?
Well, that's the other thing. We haven't seen any signs of cometary activity. No tail, no coma, no outgassing, which you'd absolutely expect from a comet, especially one that's been through the inner solar system like this.
So it doesn't quite fit either box neatly.
Not easily, no, which adds to the whole anomalous picture.
And there's something about the timing, too, isn't there? When it gets closest to the sun.
Yes. It's perihelion. That happens on October 29th, 2025. And at that exact time, from our viewpoint on Earth, it's hidden behind the sun.
Convenient. What are the odds of that alignment?
About 7%.
Yeah.
Not as low as the others, but still. Interesting. It leads to this idea. Could it be doing something deliberately, something clandestine? Like a reverse solar Oberth maneuver.
Okay, reverse solar Oberth maneuver. That sounds technical. Break that down.
Right, so the Oberth effect is normally about getting a speed boost by firing engines deep in a gravity well. A reverse maneuver would be the opposite, using a massive braking thrust near the sun, where it's most efficient, to slow down a lot.
To actually stay in our solar system.
Exactly. It's considered perhaps the optimal way for an interstellar craft to brake hard and become gravitationally bound to the sun without, announcing itself with a huge, obvious deceleration burn far out.
Huh. And didn't you mention something about where it came from, making it hard to spot?
Yeah, its incoming path was from the direction of the Galactic Center. There's a very crowded, bright part of the sky, making it really tough to pick up faint objects like this until they get relatively close.
So we basically missed any chance to, say, send a probe to check it out.
Pretty much, yeah. Which, again, fits the narrative if you're considering intentional stealth.
Yeah.
This leads the researchers to discuss non-gravitational forces. Tiny accelerations.
Like a solar sail, maybe?
Possibly. They calculate that a very small, continuous acceleration, about 1.17 millimeters per second squared, really tiny, would be enough to nudge its trajectory over time to intercept Jupiter, for instance.
That's almost nothing. You'd barely notice it.
Right. But it adds up. And crucially, this leads to a testable prediction in the paper. They say if this object is aiming for an Earth encounter, the optimal timing for arrival would be late November or early December 2025.
Okay, so we actually have a date range to watch for.
Yeah.
But look, putting alien technology in a research paper, that's bold. How do they frame this? You mentioned the Fermi paradox.
They do. They connect it to the dark forest idea. Maybe advanced civilizations stay quiet because contact is inherently risky. It's a chilling thought. But, and this is important, they strongly emphasize this is largely a pedagogical exercise.
Meaning it's a thought experiment, a what if.
Exactly. A way to explore the possibilities and calculate what we should look for if we ever did encounter something artificial. The paper itself concludes the most likely explanation is still natural.
So probably a comet, just a weird one?
Probably a comet, yes.
Yeah.
That's the leading natural hypothesis they acknowledge. We need more observation to be sure.
But even as an exercise, it sounds valuable. Thinking through these scenarios helps us prepare for future discoveries, right? Especially with new telescopes coming online.
Absolutely. The calculations, the thinking about trajectory modifications, optimal braking, detection signatures, that's all incredibly useful for the field as we find more interstellar visitors with things like the Vera Rubin Observatory.
And we have those specific things to watch for with 31ATLS itself.
Yes. Does it deviate? Does it show non-gravitational acceleration? Does it appear to be heading for that Earth intercept window later next year? We can actually test parts of this hypothesis.
It really leaves you thinking, doesn't it? When we see these cosmic oddities, these outliers, how should we react? Are they just statistical flukes? Or sometimes maybe hints of something completely unexpected? What do you take away when you encounter mysteries like this? Something to ponder. Thanks for joining us on this deep dive.